Okay, for example number 2, we have two function, 2(1) and 2(2), and then based on the question, we have several keywords. So the keywords is you need to determine your possible ROC. Okay, this is the first keyword. Second, you have to state and reason out on its stability and causality. And at the same time, you need to determine the impulse response. Okay, so we have two transfer function. First transfer function is basically on the real part. The poles is in the real values, but if you look at the second part, the poles value is in imaginary value. Why I say imaginary value? Because we have minus J4 plus J pi over 2. So we have the poles value J pi over 2 and also minus J pi over 4. So we have two different set of question, but how to solve it is very straightforward. So let's do for first part. Okay, we have your hz is equal to so what you have to do first is you need to use partial fraction. Okay, so we have half z minus 1 plus b1 plus 1 over 4 z minus 1. Okay, so basically again to use partial fraction, you need to substitute your z value. Okay, so you substitute z equal to half. So you will get, you substitute z with half, so you will get a equal to 2. B, you substitute your hz with z equal to minus 1 over 4. Then you will get it is minus 1. So basically your hz is 2 over 1 minus half z minus 1 plus, sorry, it is not plus, it is minus 1 plus 1 over 4 z minus 1. Okay, so basically from here we can determine your ROC. Okay, so your ROC, this is two poles, so we have left-sided, right-sided, two-sided and left-sided. So for right-sided, your Z is so right-sided is outside outermost pole. So your modulus Z is greater than half. Okay, so next for left-sided, it is okay. If you look here, we don't have 1 over 4. Okay, this is for ROC, we just consider at the right side, positive side. Okay, so we have to consider at the positive side of the circle. So basically negative 1 over 4, the reverse direction of negative 1 over 4 is 1 over 4. So basically again I will show you why. Okay, in example 1. Okay, so for left-sided, okay, the region is inside innermost pole. So basically your modulus Z is less than 1 over 4. When we talk about two-sided, it is in between two poles. So basically it is in between 1 over 4 and 1 over 2. Okay, done. Okay, next we need to determine the HN. So for you to determine the Hn, you need to refer to your ROC. For right-sided, modulus Z is greater than 1 over 2. Okay, so we have, we have minus 1 over 4, and then we have 1 over 2. Okay, for right-sided means all your poles will approach to right. So the function is un. 2 half n un. Okay, because right-sided approach to right. And then we have minus 1 over 4 and un. Okay, done for right-sided. Okay, for left-sided, modulus Z is less than 1 over 4. So we have same thing. Okay, for left-sided, all the poles will approach to left. The function is minus u minus m minus 1. Okay, so your Hn is Hn equal to, okay, this is coming from your partial fraction just now. Okay, we have, okay, next. Okay, 1 over 2 is approach to left. The function is minus u minus n minus 1. Minus 1 over 4 is approach to left. So the function will be positive u negative n negative 1. Okay, done for left-sided. For two-sided, same thing. Okay, so we have to do one. Okay, for two-sided, innermost pole is 1 over 4, right? So innermost pole will approach to right. The function is un. Outermost pole will approach to left. So the function is minus u minus n minus 1. So your Hn is, the inverse Z transform of Hz is okay. Next, from the question, you have to state and reason out on stability and causality. So again, same thing. Okay, for you to reason out, okay, for right-sided, it is causal, because it is right-sided region. Okay, it is stable because the region includes unit circle. Okay, for this one, it is not causal. Why? Because you have to state, because the region is left-sided region. This region is not stable because the region does not include unit circle. Okay, for two-sided, it is not causal because it is two-sided region, and it is also not stable because the region does not include unit circle. Okay, done for question 2 part 1. Okay, next we move to question 2 part 2. In question 2 part 2, okay, we have the transfer function and the poles is actually in imaginary numbers. Okay, so from here you know that your poles value is z equal to 0.5 exponent j pi over 2 and 0.5 exponent minus j pi over 4. Okay, so for you to determine the ROC, okay, you need to illustrate, okay, for your own understanding. Okay, so 0.4 is here, 0.5 exponent j pi over 2 is here. Okay, here is somewhere here is okay, so how I know this is placed here, 0.5 exponent j pi over 2 is placed here, and this one is placed here, and this part is placed here. Okay, so basically, okay, if you still remember from your chapter 5, okay, we have this relation, okay, cos theta plus j sin theta. Okay, next, we also have exponent j theta equal to cos theta minus j sine theta. So you have this one. Okay. Alright, so basically from here you can determine your ROC. So your ROC, again, this is two poles. So basically you have three ROC. So you have right-sided, left-sided, and two-sided. For right-sided means your modulus Z is greater than 0.5 exponent j pi over 2. For left-sided, modulus Z is less than 0.5 exponent j pi over 4. Why we put j pi over 4 not minus? Because of minus j pi over 4 is actually at the different direction. So remember again, we need to have modulus Z equal to modulus A, something like that. So because of that, we need to remove the minus. Okay, and then for two-sided, we have okay, done. Okay, for ROC. Okay, next we're going to determine your HN. So for HN, we need to determine for each ROC. So let's start with right-sided. So modulus Z is greater than 0.5 exponent j pi over 2. Over 4. Okay, so for right-sided, all poles will approach to right. Okay, so right with the function of un. Okay, so your hn is so 0.5 exponent j pi over 2 is approach to right. So the function is un. 0.5 exponent minus j pi over 4. Oh, sorry. This is over 4. Okay, it's approach to right also. So the function is un. So done for right-sided. Okay, next we move to left-sided. Okay, left-sided z is less than 0.5 exponent minus, positive g pi over 4. So, left-sided, all your poles will approach to left. So the function for both is minus u minus n minus 1. Okay, so your hn is, okay, so since both is approach to left, so the function is minus u minus n minus 1. Okay, for exponent minus t pi of 4 also, it is to the left, so it become minus u minus n minus 1. Okay, then for left-sided, for two-sided, okay, it is in between 0.5 exponent j pi over 4 and 0.5 exponent j pi. Okay, so for two-sided, innermost pole will approach to right. Outermost pole will approach to left. Okay, so innermost pole is to the right. So outermost pole approach to left. So you have, next we have to state and reason out. So basically for right-sided, it is causal because it is right-sided region. So please continue. Next, is it stable? Yes, it is stable because it includes unit circle. Okay, for left-sided, it is not causal because it is left-sided region. Is it stable? Again, not stable because the region does not include unit circle. For two-sided, it is not causal because it is two-sided region. It is not stable because the region does not include unit circle. Okay, done.